All right, this is lesson 3.1, functions. So let's go over some of the vocab. Somebody tell me what the vocabulary word relation is discussing.
A pairing of inputs with outputs.
Okay, do you understand what inputs and outputs are?
Going in and going out.
That's good. That's a good way to say it. So the easiest way to think about this in algebraic terms is input is usually the x values, output is the y values. And you'll see that as we go through this.
So you said input is x.
Correct. And output is y. And then the relationship between that x and y, it shows that there's exactly one output, then you know it's a function. So somebody tell me what the definition of function was. Go ahead.
A relation that pairs each input with exactly one output.
Right. Okay, let's look at, we're going to go through each of those vocab as we go through this. So when we're discussing relation pairs, that's talking about x and y being related to each other. When you get a certain value for x, it always gives you the same value for y. So let's look at example 1. So we're going to determine whether each relation is a function. There's going to be extra rules when we talk about functions as we go through this, and I want you to write in your journals. So be prepared. We're going to discuss whether each relation is a function. So for A, you have these coordinates, x and y for each of these, x and y, x and y. How would we know whether these are functions? One output. So each input has to have an output. So for instance, every input on A has exactly one output. If I put in -2, I get 2. If I put in -1, I get 0. If I put in 0, I get 2. If I put in 1, I get 0. If I put in 2, I get 0. So you have exactly one input and one output. It'll make more sense when we put this into a formula, guys. So let's look at the next one real quick. Don't have to write anything down right now.
Whoa. Wait, so we didn't even have to write the...
Well, you could put A is yes function if you want on your journals. Because you'll know to go look back, I assume, online or in your book for what the question is. So A is yes, it is a function. Yeah, we do have a book. So let's look at the second one. If I put in all the x values, 4, 8, 6, 4, 5, and then I get outputs, 0, 7. What do you notice about this one? There's 2 4s. They have different outputs. Our rule is you can't have a different output for the same input. So the input 4 has 2 different outputs. There's no way, if you were running a machine and every now and then, instead of it being a 0, it spit out a 3, that's going to skew your data, right? So this can't be a function. I might put that. You cannot have 2 different outputs for the same input. That's a rule you need to know. You cannot have 2 different outputs for the same input.
Okay, it's starting to make a lot more sense.
Yeah, it's confusing at first till we start going through it. Did you write down what I said, Charlie? Does everybody have it? All right, so let's look at C. Now they're organizing it into an input-output table. These are still, yeah, it does help clarify. These are still points. So this is a point, x and y, x and y, x and y, x and y, and so on. So if I were to graph this, -2, 3 would be a point on the graph. -1, 4 would be a point on the graph, and so on. Okay, input, output. Now, can this be a function?
No.
Why not?
0.
Because there's 2 zeros and they have 2 different outputs. So we cannot have a function here. Now you can have the reverse. We can have 2 different inputs equal the same output. I could put a 5 and a 6 equaling 0. That's okay.
Oh, that makes sense. Okay.
All right. It's probably going to be on our next, yeah, it is on our next example. So -1 comes up to 4, 3 comes up to 15, and 11 comes up to 15. this would be considered a function? Question? Yes, because of what I just told you. You can have one output equaling two different inputs. That's okay. So as long as you're not having two on the input equaling two different outputs, you're fine.
I remember doing this last year.
Yeah, you would have seen this briefly in 7th grade. So this is also a function. All right, so let's keep going.
There's monitoring progress.
Okay, so do your monitoring progress, numbers 1 through 4. I'm going to look at them with you real quick. So in all of these, you're telling me whether the relation is a function or not a function.
Not a function.
So looking at this first one.
No. Yeah.
5 has two.
Yeah. No. Yes.
Like,
yeah. 5
has two outputs.
Right. So you would say the relation is not a function, and it's because you have one input having two different outputs. I'm trying to help give you the words. One input cannot have two different outputs. Good. So the next one. 4, 8. All right, I'm just going to check them all and see if I think y'all need help. All right, you guys can do all these. I'm going to pause while you finish. All right, so now we can look at graphs of functions, and these graphs will help you quickly determine whether it is a function or not by doing the vertical line test. So the graph of a function, I don't know why this is so low. The graph of a function will, where'd my screen go? I went away for a second. Okay, so if you look at this graph, you have all of those points on the graph like we had in the table, correct?
Yep.
These would have the same points. There's a point here and a point here. There would be a point here. If I were to draw a vertical line on this graph and it only goes through one point of the line, that is considered a function. If I draw a vertical line and at any point it crosses two parts of this line, of the function, which is the parabola that you see there, then it is not a function. So if you ever have a wiggly, line on your graph and you draw a straight line and it hits 2 points, then you know, because that means it has the two outputs.
So that means that one's not a function.
This side would not be a function because here's where you have two outputs. This would be a point and this would be a point, but on the same X line.
Okay.
So that's how you know it's not a function. So graphing is a quick way to decide whether it's a function or not. All right. Let me pause real quick. All right, so let's look at example 1. Determine whether each graph represents a function. So very quickly on number 1.
No.
Yeah, if I draw a straight line right here, I'm going to hit 2 points. If I draw a straight line right here, I'm going to hit 2 points. So A would be not a function. What about B?
Yes. Because it goes in a straight line.
Yeah. No vertical line can be drawn through to hit more than 1 point, so it is a function. That goes back to the rule of for every input, you can only have one output.
If the X has two things happen.
That's what'll mess you up.
Makes sense.
Yay. All right, so go do the next 5. I bet you these are going to be fast. All right, so finding domain and range. These, have you heard these already? Domain and range?
I've heard it in science.
Uh-huh.
And I've heard range.
Math and science go together. So domain and range is easy. Just briefly pause your frustrations. So the domain of any function, and when I say the word function, think graph, think line, think y equals mx plus b. Have you guys learned that much?
No.
We're going to go over that. So when I say domain, it's all of the x values you can plug into this equation. All domain is any input value that I could put in. The range is all of the possible output values. So this little machine that looks like what y'all were talking about, the candy, is if I input a -2 into this function, aka graph, aka equation. So I put in a -2 where the x value goes. See right here, the x value. -2 times 3 is going to give you -6. So all I did was take my function, which is y equals 3x. I put in input for the x value, and then I got my output for the y value.
Okay, that makes sense.
And I could graph this point. -2, -3 would be a point on my graph of this function.
I'm gonna draw that.
Okay. So let's look at the next example. So we're going to find the domain and range of the function represented by the graph. So you need all of the input values and all of the output values. For A, we could look at these ordered pairs, right? So what are the ordered pairs on this graph?
-3, -2.
Yep. And then this first dot, -3, -2. This next dot,
-1.
-1, 0. Then we go to 1, 2. Then we go over to 3 and up to 4. So you see -3, -2, -1, -0, 1, -2, and 3, 4. All of the input values are your x's. All of the output values are your y's.
Those are going up by 2.
They are. So the domain is -3, -1, 1, and 3.
Okay.
The range is -2, 0, 2, and 4.
I kind of understand it, but
The repetition helps with this type of algebra. So just hold on to what you get and keep on going. So the domain is all the x values, and the range is all of your y values.
Oh.
So we wrote down domain is, and then all of the x's, and range is all of the y's.
Oh, that's cool.
Yes.
So domain is all of the inputs, right?
Yep.
And
Range is outputs.
That's simple.
Okay, so let's look at B.
Inputs is x or y?
X.
X.
So we need to identify the x and y values represented on this graph up here. We have a point over here. We have a point where it crosses the y line, and we have another point over here, right?
Yeah.
So if you look at this picture, they've shown you that domain is the x values. So on the x line here and on the x line here. You see the dotted line that they have? So domain is everything in the x values between here and here because it has that graphed line. So it's actually all of those values of x on that weird little funky line. Does that make sense? So all of the x's on this line. So I could say -2, I could say -1.5, I could say -1, I could say -0.5, all along the side. I could say 0.75.
You could say 1.25832.
Yes. No, I'm just saying you could. I'm going to show you how to write it so it includes all of those. Same with the y values. It's everything from this y, which is at what, -1, all the way up to +2. All right, so you would write that as the domain is everything from -2, including -2, because they're filled in circles, and then all the way over to the +3. Boy, does this look familiar?
Yeah, that
We
makes
just did it last chapter. So you have the domain is the -2 less than or equal to, your domain value is x, right? And then all the way up to less than or equal to 3.
Okay, that makes sense.
And then I would like you to write this on your paper, guys.
Even the graph?
If the graph will help you understand it. If the graph doesn't help you, that's fine.
So if it's
I feel like it would help you, so I would probably put it in
if
there.
it's like just points along, you would do the first
Individual
one,
points. If it was a line, you're going to do a range that looks like this.
I'm going to write that.
I would, yeah.
I'm not going to write the graph. I'm going to
That's
write
fine.
what you said.
So
So the range for the y value is everything from -1. See how we went down to -1 here, all the way up to +2.
So the domain is always the x?
Correct. And the range is always the y. All right, I'm going to pause and give you just a minute to finish writing all that. So once you have written all of this, then go ahead and do your monitoring progress. All right, I want to talk about each of these just to help you. Plus, sometimes the monitoring progress is like an additional example they didn't really teach you. I moved my face so you guys can see this better. So when you're looking at this first graph, this is number 9 on monitoring progress. You see these points. 1, 2, 3, 4, 5 points, correct?
Yep.
First of all, if I were to draw a line on this V, does it pass the vertical line test?
Yes.
It does. So perfect. We know it's a function. So you're going to choose all of the x values that represent the domain. So this first one over here is what? No, right here. X value. -2, -1, 0, 1, and 2. So down here, you're going to click those. Okay, and then your range values. So this is the y value. So this one is?
-2.
No, this one right here.
Oh, yeah.
4. Now there's 2 4s, right? So you only pick 4 one time. Then there's 2 2s. And then there's 0. So 4, 2, 0. Okay? All right. So let's go look at the next example. Now, quickly, you look at this and go, oh, that's not a function. But it is, because if I do the vertical line test, it doesn't cross 2 points because the parabola is going vertical. Parabola, you'll learn about those later. That's what a curved line looks like. So let's look at the domain, which is our x values. Where does this parabola start on the x line? At 1, right? And where does it end?
5.
At 5. Does it include 1 and 5?
Yes.
Yes, because the dots are filled in. So we're going to say from 1 less than or equal to x all the way less than or equal to 5, including 5.
Yep, that makes sense. That makes a lot of sense.
Now the range, where does our range start at? What's the bottom number?
2.
What's the
Four,
bottom?
four,
No,
four.
okay, try it again. Whoop. Where's the bottom of the y's? Bottom of the y's. 0. The very bottom is right here at 0. Okay, what is the top of the y's?
4.
4. So your range is going to be all the way from 0, less than or equal to, all the way to 4. And y would be your variable because that's what represents our range. Okay? It can get very labor intensive if you do a lot. So, all right. So the last vocab part to this is independent variable versus dependent variable. Those just sound like fancy words. Independent variable is always going to be your output. So the variable that represents, your input. The independent variable is always your input. So the letter that represents independent would be x.
Independent equals input, which equals
Why is I think Thompson just got it. Why do you think the independent variable is always your input?
Because it can be anything, and it tells what the input or the output is.
It's going to make the decision. It's the independent. It's the number you as the person doing the math can choose sometimes to plug it in. The dependent variable is always the output because the dependent variable depends on what you put in the input.
okay, that makes sense.
Okay, so independent is always what I can plug in. Dependent is what comes out once you do the function. So independent x, dependent y.
So independent equals input, which equals x. Dependent equals output, which equals y.
Correct. Good job. See? It just looks like a lot of information, but it's not. It's not. You guys can handle it. So let's look at this one. The function y equals -3x plus 2 represents the amount of fluid ounces of juice remaining in a bottle after you take x number of gulps. Super random. We're going to identify the independent and dependent variable, and then they're telling you the domain, and you have to solve the range. So what is the independent variable? x.
Zero, one, two.
And the dependent variable, y.
Oh, so this could take a while.
So what represents x?
Negative.
No. In this is a real life problem. What is x talking about?
Gulps.
Gulps.
Yeah.
Yep. What is y talking about?
Fluid ounces.
The fluid ounces that you're drinking. Okay? So the domain is 0, 1, 2, 3, 4. What would I do with the domain to find the range? We're going to plug them in for x. So if I put in 0 where this x is, I get negative 3 times 0 plus 12. So what does y equal?
12.
So we already know one of our answers is 12. Oh, good. I wasn't sure if they do this separately. So you can make an input-output table that looks something like this. I would do this once.
Okay.
So we're going to do it right now, just so you do it one time. After that, I don't care if you do an input-output table if you can do the math without creating it. So if I plug in 0, I get negative 3 times 0 plus 12, and then we got our output is 12. Now, if I plug in a 1, I get negative 3 times what 1 is. You're all writing and can't answer my questions.
Negative 3.
Negative 3 plus 12.
Negative. No, positive 9.
Positive 9. So then our output is 9.
There's a pattern.
We've drawn this before.
Yes.
I think in last year.
There should be a pattern because it's 0, 1, 2, 3, 4. So it's going up in equal increments.
Oh, wait, I remember this.
Mhm.
Yeah, we did do this, but
All
I
right.
don't remember for what.
So if we plug in 2, we have 2 times negative 3, which is?
Negative 6.
Which plus 12?
6.
So as I increase by 1,
So
my output decreases by,
it should be 3, 0 at the end, right?
we're about to find out. Negative 3 times 3 is?
9. Negative 9.
Plus 12.
Positive 3. I knew it.
Okay, and then my last one, if I plug in a 4,
0. 9. 3 times
You're fine.
3 times 4
You're fine.
is
You all got there.
plus 1.
So as I increase the gulps by 1, I am decreasing the fluid ounces by how much?
3.
3.
I mean, I should hope that the food ounces are going.
I hope you're not drinking from a water hose.
That's so sad.
It would never end. So yes, as I gulp one time, I can gulp about 3 ounces of Gatorade per gulp.
Yeah, it just looked like you.
Weird fun facts. All right. Does this make sense?
Yeah.
Excellent. So then it would ask you to list the range, which would be? 12, 9, 6, 3, 0. Typically, you put them in order of what the range was. So if the range was 0, 1, 2, 3, 4, you put the domain in the answers of 0 and 12 and 1 and 9 and so on.
Do we have to name the domain or no?
Nope, the question was, what is the range? Now, when you do your work for your practice, I'm okay if you've got it for you to not write this middle part every time. You can just write the points when you're doing your math. So I would write this equation, and then I'd have how I solved it every time.
Okay, makes sense.
All right.
What?
I believe you have monitoring progress, 11 through 12.
Oh, wait, no, it makes sense.
So I'm going to look at it. All right. I'm going to let you give it a shot. If I need to jump in and help, I will.